All right, here we go. Part D, intervals of increase and decrease. So to do this, we have to take a quick look at our first derivative. We have to take into account where it's going to be the numerator goes to 0 and where the denominator goes to 0. Now where the denominator goes to 0, or x equals -1, that's because of our asymptotes, vertical asymptotes. But our numerator is going to go to 0, and these are our critical numbers, sorry, at 0 and -2. So we're going to build our number line here, -2, -1, and 0. And then what we're going to do is identify what each factor does. Okay, what each factor does of the rational expression, and then look at the total. We've done this before here. So the nice thing is about a lot of these rational functions here is that the denominator is going to be squared, or up to an even power in a lot of cases. And so it is always going to be positive, except at -1, which will be 0. And then other than that, it's just going to be positive everywhere. X, all by its lonesome, is going to be negative everywhere except for 0, and then positive on the other side. And x plus 2 is going to equal 0 at -2. It will be negative on the left, and it'll be positive everywhere else. And then putting these together, in this interval here, less than -2, I'm going to have a negative times a negative divided by a positive, so it'll be positive. Negative times 0 divided by a positive will be 0. Negative times a positive divided by a positive will be negative. Here we're going to divide by a 0, and that's going to leave us with an undefined term right there, but we knew that. That was an asymptote. Negative times a positive over a positive will be negative. This one will be 0, and then it's all positive there. So based on what we're seeing here, again, remember, sorry, these correspond to intervals along the number line. So this is going to be increasing on the interval -infinity to -2, union 0 out to infinity, and it'll be decreasing on the intervals -2 to -1, union -1 to 0.